Assalamualaikum and good day class. So today we are going to learn a new topic called as the chi-squared test. So what's the difference between chapter 5 and chapter 4? So previously in chapter 4, if you still remember, we have learned about testing the hypothesis for sample mean, sample proportion and sample variance. Okay, however, for this topic, we are going to learn about hypothesis testing for population distribution. So, in this chapter, basically there are three tests that we are going to learn, okay, which are the goodness of fit test, independent test, and homogeneity test. So these three tests, we are going to use the chi-squared test in order to make a decision whether to accept or to reject the hypothesis. Okay, so let's first learn about the goodness of fit test. So the goodness of fit test, the objective is that we want to test the hypothesis that a particular probability distribution satisfies a population model. So some types of data that we have been using are the frequency distribution or the probability distribution, such as the ratio, percentage, and sometimes also normal, Poisson, and binomial distributions. Okay, so this is the example of the goodness of fit test. So basically, okay, we want to test the hypothesis that the probability distribution satisfies a population models, and we want to compare between what we observe and what we expect, which is the OI and the EI. Okay. So to find the value of the expected, we have to times the probability of the data with the number of frequencies. Okay, so this is the hypothesis testing for our goodness of fit test. So the very first step that we need to do when we do the example is that we need to make the hypothesis statement. So if our H null is true, so that means, okay, we are going to compare whether our H null is true or not using the chi-squared test and the critical value. And this is very important, okay? When we are going to find the chi-squared test, we are going to use the OI and the EI to find the chi-squared test. And we must remember that our expected frequency, our EI, must be more and equal to 5. So I'm going to tell you about this later. Okay, so this is the formula for our chi-squared test. Okay, and we are going to compare this chi-squared test with this chi-squared critical value. So to find this value, the chi-squared critical value, we need to use the statistical table. Okay, so K is for the number of categories and P is the number of unknown parameters. So normally this P normally it would be 0. And this hypothesis testing is only for one-tail test. So let me draw, okay, the one-tail test. The one-tail test to the right. So the rejected region is to the right only. There is no left shaded region. Okay, so this would be the rejected region. Okay, and this is the accepted region. So this would be your chi-squared alpha k minus p minus 1. So if your chi-squared test is inside the rejected region, so that means you have to reject the H null. However, if your chi-squared test is outside the rejected region, then you accept H null. Okay, let's see an example for the goodness of fit test. So there are 6 possible outcomes of the experiment of obtaining number 1, 2, 3, 4, 5 or 6, and these outcomes are also referred to as categories. So the question we would like to answer whether the dice is a fair dice. Okay, so remember, we would like to test whether the dice is a fair dice. So for the dice to be a fair dice, it should be the probability of every category from number 1 to number 6 dice is 1/6. Okay, so for your hypothesis statement, you can write your hypothesis statement like this, or you also may write your hypothesis statement like this. The dice is a fair dice. Okay, and your alternative is the dice is not a fair dice. Okay, so you can write your hypothesis statement like this as well. However, don't forget that you need to find the probability of the fair dice, which is 1/6, because you will need this probability to find the value of your expected value. And don't forget to find the total number of your frequency. So your n, okay, n is the total number of your observed frequency, not the total number of the categories. So you just have to plus 30, plus 32, plus 40, plus 18, plus 38 and 22 to get the value of 180. Okay, so the second step after we make the hypothesis testing, then we need to find the chi-square test. So remember, this is the formula of our chi-square test. So first you need to find the value of OI, then you need to find the value of EI. Then sub in all the values of OI and EI into the formulas. So basically, first you need to find the value of your OI. So your OI is from this one. So this is your O1, O2, O3, 4, 5, and 6. So just sub in the values into the table. And then remember to find the value of your EI. So the formulas of EI is n times with the probability of PI. So I is the number of category. Okay, so your E1 is, okay, so your N for every I is 180. However, your PI is different, but since we want to find a fair dice, so that means the PI for every category from 1 to 6 is the same, which is 1/6. So just times 180 times 1/6, so you will get 30 for every EI. Okay, so after obtaining the value of OI and EI, sub in this value into the chi-square test. And then you will get these answers. So don't forget, you need to square root the above frequencies. And then after you obtain all the values of these formulas, don't forget to find the value of the chi-square test by the summation. So that means you have to sum up all these values. Okay, you have to sum up all these values and you will get 12.532 for your chi-square test. Okay, so after you find your chi-square test, then okay, you are going to find the value of your critical. So the critical value, remember, chi-squared alpha k minus p minus 1. However, since we don't want to find the non-parameters here, so this value would be 0. So that means your chi-squared would be chi-squared alpha k minus 1. So now your alpha is 0.05 significant levels. And your k is 1, 2 until 6. So you have 6k minus with 1. And from your statistical table, you will get 11.070. So after you obtain the value of chi-squared test and the critical values, now we can make a decision whether to accept or reject the hypothesis. So now, since your chi-squared, okay, it it is more than your critical value. Okay, so if we do the table at the graph distribution, it would be like this. So 11.070 is at the boundary of the accepted region and the rejected region. So to the right side would be the rejected region. Okay. Okay, sorry class. Where is it? This one. Let me change the color into blue. Okay. So now your chi-squared test, is it more than 11.070 or less? So it should be more. Remember, for chi-squared distribution, the 0 is at the very left of the distribution. So 12.532 should be more than 11.070, which is around here. So this would be your 12.532. So since your chi-squared test is inside the rejected region, okay, or we can also write your chi-squared test is more than your critical value, so we reject the H null. Okay, so after we make a decision, don't forget to make a conclusion. So then we conclude that your experiment results do not support that the dice is a fair dice. Since we reject this one, so that means we want to say that the fair dice is not a fair dice. Okay, let's look at another example. So another example is, okay, if X is a random variable representing the number of students playing truant per day, test the hypothesis that X follows the Poisson distribution with mean 3 per day at alpha 0.01. So now they want you to test the hypothesis that X follows the Poisson distribution. So that means now your H null must be follows the Poisson distribution with mean 3. Okay, don't forget to write mean 3. Just rewrite the sentence. And the alternative hypothesis is that X does not follow, it should be the opposite of your H null, does not follow the Poisson distribution with mean equal to 3. Okay? And then don't forget the number of your observed frequency. You total this value, you will get the number of observed frequency, and the number of categories that you have here is 6. Okay, so it should start from here, even though this is 0, but for K it should be counted as 1. So 1, 2, 3, 4, 5, 6. So we have K number of 6 number of categories. So now we want to find the chi-squared distribution. However, first we must know how to find the probability in order to find the value of our expected, which is NPI. Okay, so the probability that we should know is, okay, if we look at the data, we have 0 until more to 5. So that means we want to find the probability of Px equal to 0. Px is equal to 1. Okay, Px is equal to 2. Okay, until more than 5. Px more and equal to 5. Okay, so this is the Poisson probability that we want to find. So how to find this Poisson probability? So we may use the statistical table. So if we look at the cumulative Poisson probabilities, so we look at the formulas that are given here. So these formulas means the values that are given in this table are for the probability of Px less than equal to K. However, the probabilities that we want to find here, the symbol is not less than equal to K. The symbols is equal and more and equal to 5. So how to find this value? So we have learned before in chapter 1. So I will recall again how to find this value. So for example, okay, now our Poisson is, the lambda is 3, right? The Poisson is, the lambda is 3. Okay, wait class, I erase here first. Okay, so remember, Since this is population, so your x we doesn't have the bar here, it's only x. Okay, so now your lambda is 3. That means your lambda is around here. Your lambda is 3. Okay, it's 3 here. And your k is this value, 0, 1, 2, 3, 4 until 5. Okay, so let's say we want to find the value of px is equal to 0. So now let's look at your lambda is 3. Okay, so now your lambda is 3. So we want to find px is equal to 0. So now your k is equal to 0. However, this is for p x less and equal to 0. The value is 0.0498. Okay, so what does this mean? So this means, okay, we have 0, the value of 0, and below that is 0.0498. However, 0 is the lowest value. So that means this is also means your px is equal to 0 is equal to 0.0498. Okay. How about if we want to find px is equal to 1? So first let's look at k is equal to 1 here. So that means, okay, rewrite the formulas here. Px, okay, less and equal to 1. The value would be 0.1191. 0.1991. Okay, so that means when we shade the region, this value is 4, 0, 1. Okay, 0.1991 is for the probability of 0 plus 1. So how to find the probability of px is equal to 1 only? So that means we have to minus 0.991, the total of this 0 and 1, minus probability of 0. So that means 0.1991 minus the probability of 0. Okay, we want to minus this one. So we'll get minus 0.0498, which is also equal to 0.1493. Okay. Actually, you can do this more fast. However, I will show you one by one. Okay, another one, px less and equal to 2. Okay, so px less and equal to 2 is 0.4232. 0.4232. So this is for the 0, 1 and 2. Okay, 0, 1 and 2. But you only want px is equal to 2. You only want this one, px is equal to 2. So okay, so what you should do, so that means px less and equal to 2, you have to minus with the probability of 0 and 1. Okay, so that means 0.4232 minus with this one, 0.1991. Okay, and then you will get 0.2241. So you do this until, for example, px less and equal to 4. Okay, for px less and equal to 4, you would have, okay, 0.8153. But you want px more equal to 4, right? So 0.8153 minus with px less than 3. So px less than 3 is 0.6472. Okay, so what you will get? So then you will get 0.1681. Okay, and then the last one, they want you to find the value of px more and equal to 5. So how to find the probability of px more and equal to 5? Okay, So if we draw the graph, so we have 1, 2, 3, 4, 5, 6, and infinity here. So 0, 1, 2, 3, 4, 5, and infinity. So we only want the probability of x more and equal to 5 only. So we want this probability only. Wait, let me draw it. This one. Yeah. Okay, sorry. I will change into red color. Okay. So we want the probability of 5 until infinity. So how to find this probability? So that means you have to 1 minus the probability of px less and equal to 4. Okay. So that means 1 minus px less and equal to 4 is 0.8153. Okay, and then you will get the answer is 0.1847. Okay, so that's how you find the Poisson probability. So make sure you know how to find not only Poisson, you also need to know how to find the probability for normal and also binomial probability. Okay, so now this is the probability of the Poisson. So after you know the probability, then you can insert all this value into the formulas of EI. Okay, so now the total of your M is, okay, so 12 plus 32 plus 45, 50, 35, and 26 is 200. Okay, and for your PI, so for when your X is equal to 0, your probability is 0.0498. So just sub in all the value one by one into the formulas and you will get the answer. Then after you obtain the value of OI and EI, sub in the value into the chi-square test formulas. Okay, and you will get these values. Don't forget the squared sign, the squared symbol here. Okay, and finally to find the value of chi-square test, okay, total up all these values and you will get 4.47. So after you find your chi-square test, don't forget to find the critical value. Okay, so this would be 0. So your alpha is 0.01. The question is 0.01 if I'm not mistaken, right? Okay, and then your k is, you have, okay, sorry, this is the wrong table, class, sorry. So now your k is 1, 2, 3, 4, 5, and 6. So your k is still 6. So 6, don't forget, minus with 1. And when you check your statistical table, the value would be 15.086. Okay. And then now you check your chi-square whether it is inside the rejected region or not. Okay, so when you do your critical values, okay, so this would be 15.086 and the chi-square test would be around here, 4.47. So since your chi-square test is outside the rejected region, so that means it is inside the accepted region. So that means you accept the H0. Okay, this is for rejection and acceptance of H0. So since we accept the H0, okay, we accept the H0, that means, okay, X follows the Poisson distribution with mean 3. Okay, or you could also write the opposite way. No evidence to support the number of students playing truancy per day does not follow the Poisson distribution. Okay, so that is for the Poisson distribution example. Okay, let's look at example 3. It is believed that the IQ score of all adults follow the normal distribution with mean 110 and standard deviation 10. The score of IQ test given to 250 adults are summarized below, where X represents IQ score. Test the above belief at alpha 0.05. So now, the hypothesis statement is about normal distribution. So you need to make the hypothesis statement for normal. So you can write in terms of formula, or you could also write like this. So IQ score, just rewrite the statement. Let me erase this one first. So it would be, okay, IQ score of all adults, okay, follow. Okay, just rewrite normal distribution with mean 110 and standard deviation of 10. Okay, while your H1, just rewrite this one but make it opposite. So IQ score of all adults does not follow normal distribution with mean 100 and standard deviation 10. Don't write like this, this one, because I don't want to write it too long for me, but I hope you understand. Okay, and class, since this is for population, so that means your Z score is also for population. For the Z score for the population is X minus mu divided by sigma. Okay, so that means now your mu is 110 and your standard deviation is 10. So just sub in the values and you will get these formulas. Okay, so now how to find the probability of normal? So, okay, so for example, let's say Px, how to find Px less than 90? Okay, so don't forget, okay, you must remember how to find the probability of normal. So change this x into the z distribution. So it will change to z. And don't forget our z just now is x minus mu divided by sigma. This is for population, not for sample. Okay, so that means your x is now 90. Your mu is now 110. Okay, divide by 10. Then divide by 10. Okay, and then you will get Pz is less than -2. So to find the probability, don't forget to use the statistical table. Remember, 0 is at the center, -2 is around here. Okay, less than -2. So that means the shaded region would be around here. Okay, so find the value of this shaded region. You would have 0.0228. How about this one? So that one. Okay, so for example, Px 90, okay, 100. So this, don't forget to change to Z score. So you would have, okay, 90 minus 110 divided by 10. This would be changed to only more, no equal sign. This one would be changed to Z, less than 100 minus 110 divided by 10. Okay, and then you would have P -2, Z and -1. Okay, and then when you draw the graph, okay, 0 is at the center, so the graph would be around here. Okay, so this is one example. How about this one? So this one, Px more and equal to 130. So when you change it to Z score, it would be 130 minus 110 divided by 10. Okay, and then you would have Pz more than 2. Okay, this one, it should actually, there is no equal sign. Okay, and you would get 0.0228. Okay, so this we have already learned, so please recall back how to find the probability of normal population. Okay, so after you already find the probability, so sub in the value of the probability into the formula of this, okay, and you will get this answer. And don't forget your OI is the frequency number, so from 230 until 3, and the number and the value of your n is the total of your observed frequency. Okay, and then after you got this value, sub in the values into the chi-squared formulas, and to find the chi-squared test, okay, just total up all these values and you will get 5.48. And after you have already found the chi-squared test, now find the critical value. Okay, so the P here is 0, and the K here, how many K? Sorry, this is the wrong table again. I forgot to delete this one. Okay, so how many categories that you have here? So 1, 2, 3, 4, 5, and 6. 6 category. So 6 minus with 1, and your critical value would be 11.070. And so then we need to make a decision. So to make decision, first we need to draw the values. The 0 is here. So your critical values is around here, 11.070. However, your chi-squared test, okay, your chi-squared test is outside the shaded region. Okay, 5.48. Okay, it is inside the accepted region. So that means we accept the H0. Okay, since we accept the H0, so there is evidence that X follow the normal distribution. This is for normal, right? Okay, sorry, I forgot to delete this. Follows the normal distribution, okay, with mean 110 and SD is 10. So this one as well, you need to correct this one. This is wrong. Okay, this is for the previous example. I forgot to edit this. Okay, so since we accept the H0, so that means there is evidence that X follows the normal distribution with mean 110 and standard deviation 10. Or we could also write the opposite way. No evidence to support that IQ scores do not follow normal distribution with a mean of 110 and standard deviation of 10. Okay, but what if, okay, there is another set of example. What if when you find the value of your EI, suddenly the value of your EI is lower than 5. Okay, if you look at this one, lower than 5. So remember, your expected frequency must be more and equal to 5. So this one is okay, but this one is not okay. The one that is below than 5 is not okay. So since this one is below 5, so we need to combine categories. So how to combine the categories? Okay, so that means now, okay, so now we have our, okay, our OI and our EI. So now, to combine the categories, you need to combine the one value with below 5 with the categories that is nearest to them. So 4.6 is nearest to the below row, which is 33.98, right? So that means everything's at the same row with the 4.6 need to add with the another row to the nearest row of the one with the 4.6. So that means your OI would be 2 plus 30. So now your OI would be 32. And your EI would be 4.6 plus with 33.98. So you would have 8, 15, 5, 8, and okay. So that means you would have 38.58 for this first and the second row. This one, since this is above 5, so this one is okay. So just write 6 and 5. This one is also okay. 90, 85.33. Okay, this one, since although this one is okay, however, since this one it is less than 0, so we have to combine this one, the last row, with the nearest row, which is this one. So that means now you have to add this one and you have to add this one. So that means 40 times 3, you would get 43, and 33.98 times with 3, you would have 36.98. Okay, then after you already combine the categories, then you can find the value of your OI minus EI squared divided by EI. So now use these new categories, this new column, to find the value of OI minus EI squared divided by EI. Okay, so this one you would have 1.1225. Okay, this one you would have 0.2. This one 0.2556. Okay, please check whether my answer is correct or not. And another one is 0.98. And then some all of the values in here. Then you would have your chi-squared test is 2.5578. Okay. So now after you already find the value of your chi-squared test, now we want to find the value of your critical value. So your alpha, for example, is 0.05. And now your k is, so previously you have how many k? 1, 2, 3, 4, 5, and 6. However, since we already combined the categories, so now instead of 6, now we have 1, 2, 3, 4. So now we have 4 categories. So that means our k is now 4. So 4 minus 1 is equal to 3. So that means your critical value would be 3. And you will get this value. So please be careful in class. Make sure that your expected value must be more and equal to 5. Okay, so let's look another example. Okay, the duration in minutes of a long distance telephone call denoted as X is claimed to follow a normal distribution with mean 10.5 and standard deviation 2.1. To test this claim, the duration was measured on 300 long distance telephone calls and the data were revealed as follows. So if you see here, okay, normally students would be confused to find the value of n. They thought that this 300 is the value of n. Okay, do you think this is correct? Okay, so how about this one, the frequency? Here the frequency is 5 times 5 plus 125 plus 180 plus 10, you will get 130, 310, 320. Okay, so which one is actually the value of your n? So actually the value of your n is from the frequency observation. So now this is actually the value of your n. This is the right one. Okay, this is wrong. So you need to calculate the value of your n from the observed frequency, from the table, not from the statement here. Okay, so please be careful. Okay, so please do this exercise. I will give you the answer later.